Here we're going to discuss what are called the rational zeros of polynomials. So in this video we're going to be working with polynomials that have integer coefficients, and I'm starting off with this example just to illustrate what it means to be a zero. So if I take this polynomial and I evaluate it at, let's say, 1/2, I get, let's see, p of 1/2, what do I get? 2 times 1/2 cubed minus 1/2 squared minus 6 times 1/2 plus 3. And it's going to be 2 times 1/8 minus 1/4 minus 3 plus 3. And that's going to give me, let's see, 2 times 1/8 is a fourth. Take away a fourth, and then negative 3 plus 3 is 0. So 1/4 minus 1/4, and that ends up giving me 0. So because I plugged in 1/2 and I got 0, for that reason we say that 1/2 is a zero of this polynomial. Now it's not just any zero, it's what we call the rational zero because this is a rational number. So let me write that down. Because we get 0, we say that 1/2 is a rational zero of p. That's the language we use. Now you can have other zeros that are irrational or even complex. So for example, so for the same polynomial, if you plug in the square root of 3, we find that p of square root of 3 is equal to 2 times root 3 cubed minus root 3 squared minus 6 times root 3 plus 3. And we get, well, it's going to be 2 times, and when you cube root 3, you multiply root 3 by itself 3 times. And root 3 times root 3 is 3, and then times another root 3 brings you to 3 root 3. You want to check that yourself. And then minus root 3 squared is 3, minus 6 root 3 plus 3, and that gives us 6 root 3, and then the negative 3 and the positive 3 cancel, but then we still have minus 6 root 3, and that's equal to 0 as well. So we plugged in root 3 and we got 0, and for that reason we say that root 3 is an irrational zero. So it's an irrational zero of p. Now, irrational because, well, root 3 is an irrational number. It can't be written as a fraction. So 1/2 was a zero that was a fraction, a rational zero, and root 3 is an irrational zero of p. Okay, so in this video, we're going to be discussing how to find the rational zeros of polynomials. How do you go about finding the rational numbers that when you plug them into the polynomial, you get 0? So it turns out we have a theorem, and then we're going to use synthetic division to execute this. So let's see how this goes. So here's our rational zeros theorem, and it looks intimidating. We'll go ahead and read it together, but there's only really one part you need to focus on. So we're starting with a polynomial, an nth degree polynomial. So this holds for any degree polynomial you want to handle, as long as it has integer coefficients. So all the coefficients are integers, where the lead coefficient an is not 0 and the constant coefficient is not 0 as well. Okay, then what it tells us is this. Every rational zero of the polynomial is of the form p over q. So this is just how you form a rational number. You have an integer divided by another integer. And here's the important thing. The numerator is a factor of the constant coefficient. So you see the constant coefficient right here? The numerator of the fraction is a factor of that constant coefficient. And the denominator is a factor, the q is a factor of the leading coefficient, so of this coefficient. So basically what you do is you test all the factors of the constant coefficient divided by all the factors of the leading coefficient. And what you do is you test all those and you see if they are zeros of your polynomial. Now this theorem doesn't say that they all are zeros. It says that your zeros will be included in that. Okay, that's how you go about finding. You test them, and whichever ones are zeros, there you go. Okay, so it doesn't give you, it says where to find them. You have to still look for them. Okay, let's see how this goes. It's an example. So we're going to find all the rational zeros of this polynomial, okay, and we're going to write the polynomial in factored form after we do that. Now this little star here reminds us, and this is telling us what to do. Use synthetic division to check all the possibilities. Okay, so the first thing you do is, according to the previous theorem, you list all the possibilities. And all you have to worry about is the constant coefficient and the leading coefficient. So you take all the possible factors of this and divide it by all the possible factors of that, the leading coefficient, okay? So it's going to be, let's see, the possible factors of 3 are 1 and 3, and the possible factors of 2 are 1 and 2. So you write 1 and 3, I'm just going to list some possibilities here, divided by 1 and 2. And so positive and negative. So what you do is so notice that these are all the factors of the constant coefficient, and these are all the factors of the leading coefficient. And then once you do that, you take all the possibilities. So 1 divided by 1, and then 1 divided by 2. And then we go into 3, and 3 divided by 1, and 3 divided by 2. So let's write that down. We're going to have here, I'm going to list our possibilities right now. So we have plus or minus 1 over 1, plus or minus 1 over 2, okay, and then plus or minus 3 over 1. You list all the possible fractions, plus or minus 3 over 2. And what that our previous theorem tells us that if this polynomial has rational zeros, they'll be included in this set. So how many numbers are there to check theoretically at this stage? Well, there are 8. Positive and negative 1, positive negative 1/2, positive negative 3, and positive negative 3/2. Okay, so we're going to check them using synthetic division. And we're going to start off, usually we start with the simpler numbers, so I'd start with positive or negative, I'd start with positive 1. In this case, just for illustrative purposes in this video, I'm going to start with positive 3. Let's see how that goes. So using synthetic division, I'm checking to see if 3 is a factor, or 3 is a 0. So the way synthetic division goes is you write this upside down division symbol, and then you list the coefficients. So we have 2, -7, 8, and -3. And let's see, you bring down the 2, so we get 6, -1, -3, 5, 15, and we get 12. Now, the number at the end is the remainder, and the fact that this remainder is not 0 tells you that 3 is not a rational 0. Okay, so this tells you 3, what you're checking, is not a rational 0. Okay, so I wanted to start with that for 2 reasons. Well, just one reason. I wanted to show you what it looks like when you test something and it doesn't work. You get a non-zero number right here. So let's go on and check a number that another possibility here. So I had positive 3. I could also check negative 3. Let's go ahead and check positive 3/2. I want to show you what it looks like when you check a fraction where there's a denominator that's not 1. So I'm going to check positive 3/2. And what happens when I do that? Well, I list the coefficients again. So 2, -7, 8, -3. And you bring the 2 down. You can put a 0 here. I do that. So it's a 2. Multiply these together and you get a 3. And then it's going to be, let's see, -4. Multiply these together and you get, well, it's going to be -6. It's going to be a positive 2. Multiply these together and you get a 3. And that brings you to a 0. Okay? And again, the number at the end is the remainder. And if the remainder is 0, that means that indeed you have that this number is a rational, it is a 0. Okay? So this tells you, the fact that that 0 tells you that 3/2 is a rational 0. Okay? Now, you can also, it turns out, you can also use your, so the fact that this is 0 tells you that it went in evenly. And so what you have here left over after synthetic division, that's the quotient. So in other words, upon division you get this, x minus 3/2, right? Because 3/2 goes in evenly, and that tells you that x take away 3/2 is a factor of the polynomial. So x minus 3/2 times this, which is 2x squared minus 4x plus 2. So whenever you end up getting a remainder of 0, you can write your polynomial in factored form as x take away that number times the quotient. And that can be written as x minus 3/2 times, and you can factor this further, it's 2 times x squared minus 2x plus 1. And then you can write that as 2 times x minus 3/2 times x minus 1 quantity squared. Okay? And that is the factored form. That's the factored form of this polynomial. So in other words, that's how it goes, is you list your possible rational zeros, you test them. If you find one that works, you write x take away that 0 as a factor, and then you write that as your quotient, and then you try to factor that quotient, and that'll give you the factored form of your polynomial. Okay, let's take another one like that. Let's find all the rational zeros of p of x is x cubed, take away 3x squared plus 4. Oh, before we do this, one last word about the previous example. Something I want to mention. Notice that when you look at this, you can see that x take away 1 is a factor as well, right? Now, what that means is that if I would have tested positive 1 here, because that was a possible rational zero, I would have found that it worked. I would have gotten 0 here as well. So the reason I didn't start with positive 1 is I wanted to show you what it looked like with a more complicated rational zero like 3/2. But indeed, if you're handling these problems on your own, in homework problems, you would start usually with the simplest possible rational zero, so positive 1, for example. Okay, let's go back to our example. So let's find all the rational zeros of this. So just like before, you list all the factors of the constant term. So it's going to be 1, 2, and 4, right? Those numbers all go into 4. And then you list all the factors of the leading coefficient. Well, the leading coefficient is just 1, so the only possibility is 1. So it's plus or minus all those combinations. So that leaves us with this. Plus or minus, let's see, 1 over 1. Plus or minus 2 over 1. And we're going to also have to check plus or minus 4 over 1. Okay? And just like before, you would usually start with positive 1, but for illustrative purposes in this video, I'm going to start with negative 2 to show you something. So if I test out negative 2, what do I get? Well, it's going to be a 1, a negative 3. Now you see how it's missing the linear term, the term with x in it? That's why you have to put a 0 in there. Don't forget that for synthetic division. And then positive 4. Okay, bring down the 1, and then you multiply and you get negative 2, negative 5, multiply and you get 10. So it's going to be 10, negative 20, and negative 16. Okay, so here's your remainder, and it's not 0. Okay, so once again, I can see that that implies that negative 2 is not a rational zero. So even though it was in the list, it didn't turn out to be one. But this also illustrates something else that we're going to see in a future video with synthetic division. Do you see how these numbers alternate positive and negative, positive, negative, positive, negative? When that happens, that tells you, and we're going to talk about this more later, it tells you that the number that you tried, if it's a negative number, it tells you that the zeros can't be lower than that number. Okay, so let me write this down. The fact that these alternate, positive and negative, alternate positive and negative. Okay, that implies that you don't have to worry about numbers that are less than negative 2. So looking at this list over here, right, I thought, I saw this over here and I said, oh, there's negative 4 right there. Turns out I don't have to worry about the negative 4. I know the negative 4 is not going to work because I see that I had alternating positive and negative for negative 2. Okay, and that means that negative 2 is what we call a lower bound. You're not going to be able to find a 0 less than negative 2. Okay, so that's a little shortcut that we'll talk about. But let's go ahead and try negative 1. Right, negative 1 is not less than negative 2. So once again, list the coefficients, 1, negative 3, 0, and 4. So it's going to be a 1, negative 1, negative 4. It's going to be positive 4, 4, negative 4. Okay, 0. Okay, we found that it works, right? So the fact that it's 0 implies that negative 1 is a rational root. Now that means you can also use, that means that you can use what we found to factor that polynomial. So it's going to become, well, it's x take away that number. In this case, it's going to be x plus 1. and then times the quotient, which is x squared minus 4x plus 4. And then we can go ahead and factor this, and we get x plus 1 times x minus 2 quantity squared. So our rational zeros are -1, and I can also see a rational zero of +2. Notice that I didn't find +2 by using synthetic division, even though I could. I just found it by factoring. So if you can find it by factoring, you're fine. Notice that it is listed as one of the possibilities. So if you didn't do this factoring here, you'd go ahead and run through all the possibilities and you'd find +2 worked as well. And you're going to also, this also implies that -2 does not work, and +1 doesn't work, and nor does positive and -4. Okay, that is, of all these possibilities, the only ones that work are -1 and +2. Okay, we're going to have more to say about the rational roots theorem and finding rational zeros in future videos. Until next time.